So I suppose just to recap where we are, we've been primarily focusing on Workspace and Studio with a bit of, I've been showing you dashboard occasionally. We went through the key measures. We talked about some of the objective measures and then the ones that related to specs, that it's detecting things that you have asked Structure101 to detect. We went through Workspace, the basic companion for primarily for the programmer, if you like, and navigation between Workspace visualization and the code in the IDE. And then we looked at Studio and we covered the basic analysis, the various views that you can get in Studio, and we did some restructuring. So in this session, we're going to focus on the speccing side of things and also the usage with Workspace, so using Studio and Workspace together. The speccing side of things, basically there are three main aspects for doing specifications. There are what we call modules, which I showed you a bit of actually already. There's a bit of an overlap there with restructuring, because quite often that's what you're doing, is you're creating new modules from existing modules. And I'm going to show you today like a bit more on modules and how you set those up. What are the panels within the UI, defining visibility, and also using deprecation as part of the module's control, if you like. Then we're going to look at structure specs and architecture diagrams. And finally, I'm going to just look at using specs in Workspace. How does that kind of crossover work? Okay, so coming back to Studio then and focusing on modules. Now, in the case of Java, Structure101 treats Java modules as real things in a sense. So real things in the sense that your physical code base is going to contain modules. They're probably going to be Maven modules. They may map to what the IDE considers to be modules. There's a Maven plugin for IntelliJ, for example, where it maps. IntelliJ has, I forget if they call them modules or projects or things inside IntelliJ, but it aligns those with your Maven specs, if you like. And what we did, if you remember, we extracted some of the functionality out of core as it related to licensing, and we created a new module. And you may recall that it showed that, you've got some missing module dependencies there. That was the beginning of the speccing part kicking in there. So let me delve in a bit more on that. First of all, I'm just going to adjust the user interface a little bit here. This is what I would suggest you do when you start using modules as a focus, if you like. It's worth doing the following. At the moment, you've got this structural overcomplexity that relates to cyclic dependencies and tangles and fat and overcomplexity. I would probably get that out of the way, along with the list that's underneath it. This is the sort of top tangles and fat kind of list. We're not really wanting to focus on that just now. What we want to look at is what are our modules and what are the allowable dependencies between the modules. I'm just going to readjust the user interface in Studio now to accommodate the modules aspect rather than the structural overcomplexity aspect. And these aspects, you can work them together, and often you do, but I'm just going to shift so there's less stuff on the user interface, and the stuff that's in the user interface is related to my work with modules, let's say. So what I'm going to do is I'm going to just grab this bottom viewer here and pull it up over the top of the overcomplexity stuff, because that's kind of where I want to focus things at the moment. At the moment, there are no module violations, okay? I'm also going to disable this option here, which is the thing that highlighted the tangles. We're not really wanting to focus on tangles at the moment. And also this one here, which shows the feedback dependencies, if there are any. What I really want to show are there any module violations? So I've done a little bit of a shift there, if you like. Now, the other place you're going to look at is in the project settings. When you open the project settings dialog, it'll probably be showing you this. You're going to skip through the granularity, the externals, and now we're on the modules tab here. And this one here, modules requires violations. This is where, if you remember, when we extracted the licensing code out of our core module, it highlighted for us already where the module-to-module dependencies that are missing. They're called requires violations, if you like. So you have to add a requires dependency between the modules, let's say in Maven or in your IDE, in order for the code to be visible at compile time between modules. So that was kind of handy already. And the effect of that was, if you remember, I pulled out, let's say, the Nalpiron stuff here. I created, first of all, a module, add a module, add module here, and I called it licensing. And then the first thing I did was I dragged our third-party licensing into that. And that showed me that, oh, hold on a minute, I've got a couple of problems here, this one and this one, because you're telling me I've got this licensing module, but I haven't expressly given permission or visibility from the build tools or the core onto that. And the way I fixed that was I just selected the two of them and I did module allow on both of those. And what that did was it gave me this additional uses from the module to the module. That uses there is that requires permission. That's giving permission for the module core to use my new licensing module. Up until now, because I pulled in the modules as they are on the disk, it already knew that there's dependencies, for example, from parser gen to core. It gets that from the IDE. That was already there. But now I have to say that licensing here can be used by core and also can be used by my build tools. So that's that requires aspect. The other aspects that are there are the, for example, this one here. If I take a look at this one, this is the module API violations. I'll show you what happens when I click this one. What this is enforcing is that you now have to have, if you've got that checking in place, you've enabled it, it's forcing you to declare within each module what is publicly visible externally to the module. And when you switch that on for the first time, you're going to find that everything, every module to module dependency is going to be a violation. It's showing the violations because I selected this one here, right? And the reason it's doing that is because I haven't given any visibility. I haven't made anything public within this module here. So let me just select a couple of these ones here, maybe this one here. Yeah, let me select those three. I'm just going to filter it on those three for the moment so that we can see what's going on. And what it's saying is there's a problem here in that something in this KW folder is being used. In this case, there's just one class in here. It's being used, but I haven't said that it's allowed. I haven't said that it's public to the module. Therefore, we've got a problem. And I have a choice here. I can basically make the, let's assume there may be lots of different classes in here, obviously. In this case, there's only one. But I can actually make that class public. And you can see as soon as I did that, the violation has gone away. And now I've just got this other one here, this other violation going on here. And so let's explore this one. It's something inside assemblies, and it's going to here and here. So the problem is just there's only one violating item on this side here, ProGuard scripter. This thing here, this method here is making two references to something in an external module that is not declared to be public to that external module. So I have a choice. I can choose what granularity I want to make public to the module here. In this case, I'm going to say, well, look, let's just make this whole CView package visible externally. So I go module, make public to the enclosing module. Oh, I have to do it right the way down to the package that's actually used. So I did that slightly incorrectly there. There we go. Now I got rid of that. I'm just going to tidy this one up. Module, make private. So now this package here is visible externally. Therefore, there are no violations of my module API definition. Now, this could be very useful to you if you were, for example, thinking of moving to Java modules, because it would let you do the tidy up without actually flipping the switch and moving to, Java 8+, whatever it is that has the modules in it. The problem that people have with using Java modules is that it's all or nothing, and nothing will compile as soon as you flip to Java modules until you tidy up all of your API definitions, which takes time, and you're working during that period of time without the compiler. So Structure101 would let you define the modules in this way, in a Structure101 way, so that they are consistent with your target Java modules architecture that you're working towards. So if you wanted to do that, you could do that. Let me go back in, let me clear the filtering again. Now, remember, you have to do that for all your modules is kind of the snag there. So it takes a bit of time, but all you're doing here, it's really just noise in the user interface within Studio. So you can kind of gradually move towards that without that being a particular problem. For now, I'm going to switch that one back off again. Let me switch that one off. And let me just show you this other one here, deprecation violations. If you want to actually use deprecation as a way to remove the usage of things in a module from that module's API, if you like, you can switch on this this deprecation checking, and you can see here we have a few cases of deprecation here. You can see here there's actually quite a lot. There's quite a long list of deprecated stuff. The deprecated stuff is here. Actually, here I see a lot of the things that are using deprecated things are themselves deprecated. So I may say, well, that's not necessarily a problem. But there are also things that are not themselves deprecated that are using something that's deprecated. So here, this get weight here is using something that's deprecated. Okay, I guess it's one of these things on the bottom row here. But yeah, you've got a way now to switch on deprecation checking so that it surfaces in your dashboard and in Workspace, if you like, and you can ask people to start removing things that are deprecated. And so let me show you what that would look like in Workspace. If I do a save here, and then I jump across to Workspace here, and I just reload my project here in Workspace. Down here, you can see the modules list. This is the problem items list. The modules category has a whole load of problem items here, 465 of them. They're all deprecation violations. And I can go to any of those. I can quickly go there and say, okay, this thing here, all those red lines there are all usages of something that's deprecated. So they need to be fixed. Now, as I mentioned earlier, the thing that's using them is deprecated, I don't necessarily need to fix it as such. But what I can check is, hold on a second, what I notice immediately actually on this one, this collect method here, itself is no longer being used by anything. Okay, it's spotlit at the moment. So if there was any incoming dependencies, I would be seeing them here. I'm not actually seeing them here. Therefore, I can assume that actually the solution here is just to remove this deprecated method. It's presumably been deprecated for a while. People have stopped using it because it's deprecated. And now I can just go ahead and delete that in the code. That would get rid of what looks like about 20 separate deprecation violations. So in this case, that's quite an easy fix. If I move around here, all of these things actually are deprecated. This is all goodness. Trying to find one that's not deprecated actually is quite difficult. So yeah, this wouldn't be uncommon, because when you deprecate something, you're probably going to get a whole load of other things that are used that are deprecated. Here's one here where find cell for is not itself deprecated, but it's using something that's deprecated. So maybe I just have to refactor that so that it's using whatever it is that replaces this get pattern cache. That would often be the pattern. It may well be in the comments for the get pattern cache. Deprecated item, it might suggest what it's deprecated in favor of. So that's the module stuff. I don't say much more with that. You can see there, it's very flexible. There's lots of ways you can use it that make sense to you for managing a bunch of modules with APIs that are public potentially, but you don't have to use that feature, but you can. And deprecation then, which would usually be things that are in the public API that have been deprecated. And you can start pulling those out. Okay, let me just go back here, and I'm just going to switch these off for now. And now I'm going to move on to the structure spec side of things. Let me just undo a couple of actions that I had done here. Just undoing, I had created the licensing, just undoing that here. So just to not confuse my demo, I'm going to remove that. So now let's look at the structure spec. Where we find the structure spec is over here on the overlays. I have to make sure the sub tab here, structure spec, is selected. So I have two sub tabs here, one for architecture diagrams, which I'll come back to in a moment, and the structure spec itself, which is now selected. And what it's going to let me do is a few things. I'm going to show you the first of those. It's going to let me group things together that belong together from an architectural point of view, just to make the higher level a bit easier to understand. Then it's going to let me define the layering between items myself. Up until now, what you've been seeing is the layering that is based on the actual dependencies. So it's a layering that is calculated by Structure101. The structure spec lets you take over control of that as an architect. And then the third thing you'll see is it allows you to control the visibility of items, which items can use which other items and that type of thing. So I'm going to go back now to Workspace here. Let me just reload here. And the first thing you're going to notice here is that the LSM here is, oh, why is it picking up my licensing? I thought I did a save there. I have to do another save. I forgot to do a save after I had reset my action list. The first thing you're noticing here in this visualization is it's not particularly useful in the sense that it's very wide. It's a very flat, wide structure. And a lot of the time, most of the stuff in here isn't that important to me. Let's say I'm one of the engineers working on the Java stuff or the .NET stuff. I don't necessarily need to see all that other stuff all the time in my visualization. And also, when some of these modules are being modified or worked on, there tends to be a little handful of other modules that do need to be worked on. So let me give you an example here. If I look at the .NET parser here, there's only a couple of things that use the .NET parser. There's this addition CAA and .NET, and then addition S101 for .NET. These things kind of go together. What would be very useful for me would be to actually group them together to capture that architectural aspect, if you like. So let me unspotlight that and go back to Studio. Now, at the moment, there is no structure spec defined in the Structure 101 project, so I'm going to create one. I just clicked a plus button there. I'll come back to that. But what it's doing is a structure spec always grows from the top level of your project downward. You can grow deeper into the structure, but you always have to define it from the top down, which is actually the way that you tend to work with an architecture. And what I wanted to do was group together the .NET related modules here into a single module. So I'm just control clicking here and chasing the dependencies to help me find the other .NET related modules. And now I'm going to create a wrapper cell around those three .NET related modules. I can also give that a name up here. And when I select it, there's a sort of a properties panel on the left-hand side. And .NET, I've called it. I can even give it a color if I want to do that. So let me just give it a, I don't know, a nice pink color so we can find it easily in a moment. And now I'm just going to save that. So I do a save here. And let's take a look at that in Workspace. And I'm going to hit refresh. Or actually, I'm just going to do a reload just to make double sure that it picks that up. And now you can see it's sort of changed a little bit. There's a few things that have changed. Some of these have become grayed out. Just ignore that for the moment. What that says is that those cells in the structure spec contain no code. I think that's probably because I haven't compiled my whole project at the moment. So there's nothing in the model for those grayed out cells. So just ignore that for a moment. That's not really germane to the discussion. The other thing you'll notice is there is a grid pattern has appeared around the cells here now. That wasn't there before. What that is indicating to you is that the layering here is not generated by Structure 101. This layering is defined now by the structure spec. So if you remember before, without the structure spec in place, if I made some changes to items, to the code, it was causing the layering to change. That won't happen anymore. This top level, at least, is purely under your control. And the only way to change this layering now is by going back here and changing the layering in the structure spec, which I will do in a moment. But what we're focusing in at the moment is this ability of the structure spec to group together modules with a common purpose. So now there are three modules here where there were three modules now at the top level. There's a single .NET grouping at the top level. That's just an architectural entity now that I can expand if I want to see the internals. Now, let's continue that. I noticed, for example, if I do a spotlight by doing command click on parser CPP, I see there's a few CPP related modules here. Likewise with Java and JavaX. If I click on JavaX is there, parser Java is there, there's a few related ones, etc. Okay. But what I want to do is more of the same now. What I'm going to do is back over here now, I want to do similar groupings as I just did for the other language packs. So I'm going to, I can go ahead and do that, but rather than taking the time and doing it, I'm just going to grab the one that I performed earlier. Most of the things like action lists and specs and architecture diagrams and various things, there are ways to export the information that's contained in those into separate files. And that can be useful in various ways, but I'm going to use it now for demo purposes. I'm just going to import this. It's an XML file that shows me this particular spec here. So what I did was, if you remember, this is the bit I had already done, where I grouped three modules into the .NET module. Okay. Then I did something similar for C++, and you can see there's half a dozen or so C++ related modules. I pulled those all together there. I did something similar for the other languages. There's Java here, expand Java. I can see that there's a bunch of Java related modules, etc. There was also a few vendor related modules here. So I pulled those into one, and that's it. Core is not a grouping. That's a pure module sitting at the bottom. That's the big one. It doesn't really make any sense for me to group that into other things. Build tools, likewise. You can tell by the icon here, it's actually a Java module. Whereas these ones here are just logical groupings of Java modules. The other thing you may notice is I have grouped here a bunch of groups. So the various language groupings here for Java, .NET, C++, etc. I pulled all of those into another group. I just select them in the structure spec and group them together. So all the language related stuff is now in a single grouping. And I used a bit of color just to make things sort of stand out. You'll see it's kind of useful, particularly in Workspace. Colors makes it immediately obvious to the user where he is and what he's looking at and in what part of the spec are we looking. So now if I save this and jump back to Workspace and reload this, and we'll see what that looks like here. And I'm seeing kind of what I saw in the Structure Spec editor in Studio. But now in this case, when I drill down here, let's go into Java here. Now when I drill into these, I'm starting to see the actual code in each of these here. So this is a view in a sense that you don't really get as such in Studio. What I'm looking at here, say I drill into core, I'm looking at the top level, I'm looking at the structure spec, okay? As I drill into the structure spec, it's kind of like I no longer see the horizontal and vertical lines, that kind of grid pattern here. This bit here is at this point in time not specified. I'm now kind of like in the levelized structure map part of Studio as I'm drilling around in here. So what this is letting me do in Workspace is to see at the top level what is my architecture, but drill down to the actual code level and see those dependencies here. So let me follow through on that. I'm going to go back over to the IDE here. Bookmarks, and it's this one here. Let me close that. Now, if you remember, if I alt-click on some of these ones here, I do some spotlighting here. Let's just sort of see the effect now, I suppose. Here I'm seeing, because I'm using color here, I guess it's obvious that I've just got a single grouping here. Everything that uses this remove column is local to my current module. If I go down to the next one here, I see that now things have expanded a bit. Now I'm getting usages from some of the language areas, specifically the C++ grouping and the Java grouping are using this clear one here. And now the set data. Set data is fairly widely used. I can see it's used a lot internally to core, but it's also used by several more now of the classes, and within those classes, methods and fields, within several of the language packs here. Okay, so I'm getting a real feel for now. What I'm looking at, if you think of it this way, I'm about to make a change, let's say, to the set data method in the code. I did a quick check in Workspace, and I'm seeing the scope of the things that might be impacted when I do that. And I can, at a glance, see not just the dependencies, but I'm seeing the dependencies through the defined architecture in the structure spec, okay? So that's the sort of power of the structure spec specifically, and uniquely, the structure spec marries with the details of the code model and lets the developers now see stuff in the context of the architecture, see the detailed code level dependencies, but seen through the lens of the architecture. So that's the first thing we did, was a fairly simple thing, I guess. We did some grouping here. Now I want to do something a bit more. I want to start thinking about it. It also actually is defining some rules, although I haven't sort of homed in on that yet. We did more than grouping here. If I look here at the Java stuff and let's say the .NET stuff, you'll notice that the Java group here and the .NET group and the generic group, all of these, and the C++ and the Ada, what we've said here is that because these are all on the same row, the same level in the structure spec, there should be no dependencies between them. So we're not just grouping things together now. Once we create a structure spec, we are now implicitly, explicitly defining some rules about the dependencies here. And so what we're saying in this case is none of the code in any of the language packs should use any of the code in any of the other language packs. Now, if that code were to surface, it would surface as a violation to the structure spec. So that's something that we're not breaking that rule at the moment, but if we were to break that rule, it would become immediately obvious. I'm going to create another type of thing, another type of spec here. Well, let me show it to you actually in a different way. If I were to go into the C++ grouping here, and let me say, for some reason, I said, well, do you know what? This parser here shouldn't use anything else. It should be down at the bottom level here. I can move it down there. And because I'm saying it should be at the bottom level from a dependency point of view, it shouldn't use anything above it. And now I'm getting these dependencies here. They're not feedback dependencies in this case, because there was no tangle here as such. What I'm saying is now that these dependencies themselves are illegal dependencies, and they are now shown as violations. And you can see those there. If I save it now, the guys will come and they can chase down these violations and remove them if that's what you want them to do. Another thing that we can specify now in a structure spec, other than the layering, is the visibility. So let's say in this case, I observe something here. You notice the dependencies coming out of build tools. There is no dependency on these additions here within Java, but there is a dependency here. And so what I can do here is I can say, no, that's wrong. That looks like a mistake. That shouldn't have been created there, that problem. And what I want to say is, you know what, one way to express that within a structure spec, other than the layering is awkward here. I don't want to move the whole Java on top of build tools. That doesn't work well. But what I can say is, actually, this addition here is private to the Java grouping here. And the way I do it here is currently it's public. I can just double click here and it becomes private. You see the wee padlock has appeared here. And not just that, but a violation has appeared. There's a dependency with a dashed line that doesn't go away. That's a problem that is created now because I've said that this module is private within the Java area. Now, I could do that, and I could go ahead and I can save that to the code, and people can come along and I can assign somebody to fix that problem. But now, thinking more with an architect's hat on it, I'm trying to be more proactive than reactive. I'm going to say, well, actually, all 4 of these additions here should not be used externally. I don't want to come in the morning just to discover there's another dependency has appeared onto this module, and now I have to make it private, and then we have to go through the change cycle after the fact. I can express that up front much more concisely by, rather than making this module private, let's turn it back to public for the moment, I'm going to create this grouping here. And so I multi-select those 4. I'm going to create a wrapper cell around them, and I'm going to call that implementation. Implementation. And I'm going to say that basically the implementation itself is private to the Java grouping here. So I just double click there, it becomes private. And now I'm seeing the same thing. I'm seeing a violation from build tools down to this module here, but it's for a slightly different reason. It's because the module itself is in a private group. And then tomorrow, if I come in and there's a dependency on any of these other modules that are in the implementation group, that will be flagged as a problem. And more importantly, if you like, if I save here and go back to Workspace and reload here, more importantly, the developers themselves now, as they're making changes to the code, they see that they have a problem at the moment. Oh, I just have to make that visible. It's spec violations has to be visible. I can see there's a problem here, and the guys can see it also in the list down here, and they can go here, and they can click on something here. There's my problem here. Something's being used here that shouldn't be, right? So they can go ahead and fix that. But more importantly, in a sense, is if they create a dependency onto one of the other modules here, that will immediately get flagged as a violation. And so they can actually detect that they've created a violation to the architecture before they check that change into the code, which is the cheapest time to detect those things. It's much better to detect it before the guys go on and do some work. So that's all I want to say really about the structure spec. I think you've sort of got the gist of it there. A very useful way to, I suppose, create an architecture that's intuitive, it's part of the visualization, and it checks a bunch of different kinds of rules continuously, or at build time, or let's say after a build has happened and your architect goes into studio, it can be detected at any point in time during the code change and update and build process. The final thing I just want to show you is the architecture diagrams. Architecture diagrams you can have multiple of. The structure spec you're only going to have one of because of its special role as the architecture through which you see the layering and the colors and the groupings and stuff in the structure map in Workspace. And so it only makes sense to have one of those. It's very much tied to the physical structure of the code. Architecture diagrams are much more free form. You can have lots of them, as many of them as you want. And they're not as tied to the physical code. That's the key point, really. So I can create a new architecture diagram here. When I click that, it actually pops up this dialog here. I can start with an empty diagram, or I can start with the existing code. Let me do this one for now, because it's sort of useful to see it. I can choose how deep. I'm just going to say the current depth is 1. Let me just do that. What this is now really is a structure spec without doing anything else to it. It's kind of the same as the structure spec. The difference is that I can do other things now. So let's go back to the .NET as an example here and just select the various .NET things again. And I'm just going to create a wrapper cell around those as I did the last time. What I can now do that I can't really do in a structure spec is select all of those, deselect the .NET grouping there, and just delete them because I want to say something about the .NET stuff. Let me show the items not associated here. I can pull core in here if I want to. I can start adding things to the diagram if I want to. I can also do other crazy things. So let's say one of the rules I have is that this grouping here of .NET stuff shouldn't any of the other things other than core. Core is already on the diagram. And I've said about the relationship between the .NET stuff and core here, because I put it at the bottom. I've said .NET stuff can use core. That's fine. Other than that, I don't want anything else to use the .NET stuff. So what I'm going to do here is I'm just going to create a new cell. And if you see down here on the selected cell, there's a pattern. I'm going to just put a wildcard in there. That is now populated with, there's a whole bunch of stuff now that is now associated with that cell. Let me give it a name, and that might make a little bit more sense here. The name here is not .NET or core. When I created that wildcard, what it says is, give me everything that's left other than what you've already allocated to cells on this architecture diagram. And what I want to say here is, actually, it is allowed to use core, but it shouldn't use anything in .NET. Okay, so anything other than core or .NET here should not use anything in the .NET. Well, let me give that one a name there. And give that a name. This is the dot. There's my .NET modules. So I can also use visibility. I can use various things like that. I can create overrides or say, oh, well, that's not quite what I want to say because that dependency is okay there. I can derive an override there. And that little green arrow, that dependency has become green there. Don't know if you can see that. Meaning that that's okay. I'm allowed to override the rules of the diagram there. But these ones here, there shouldn't be those dependencies there. So you can create various on-the-fly, add a few cells, put them on the diagram, mess around with patterns. Let's say I had a pattern star dot test dot star. That would pull any test code from any of the modules in the code base and pull them into that cell on the diagram. You notice the icon here indicates that this isn't a module, it's not a package, it's just a whole bunch of things that are now associated with that cell. So that's the power of the architecture diagrams. You can use them for any number of strange dependency rules that you may want to enforce on your project. Now, they will be picked up at build time. You can break the build based on these ones and that type of thing. So that basically they're designed to be picked up there. You won't be getting reports on these on architecture diagrams. They're very much for the architect to do his thing. So you won't be getting reports of those directly as it stands at the moment within Dashboard or Workspace. Okay, final thing I just want to point out there. I was jumping around between Workspace and Studio. So I just want to show you how all of that joining up, that workflow kind of happens. I'm going to just share a slide again here. Let me show you how that is happening here. So first of all, you remember we have a connector that plugs into your IDE. That connector, I can actually show you that if I go into the IDE and I click on the Structure101 panel down here, you can change this from, I'm not sure what it defaults to exactly, but you can set this. It creates a HSW file. The connector only sees these HSW file. They're called a settings file. And that's all the connector does. And it dumps all kinds of interesting and important information for Structure101 out of the IDE. It says, here are the modules, here are the module-to-module dependencies, here's where all the bytecode gets created and that type of thing. So that's sort of non-negotiable in a way, other than you can put that in a different location. So let me go back to my presentation here. So the HSW gets created, and the HSW points, as I said, to the bytecode and other things. It extracts a lot of useful information from the IDE. And Workspace can be used to point directly to a HSW. And again, if I go back to a Workspace here, when you open a file, you can see this, right? You've got this option to point to a HSP, or actually a repository file, I'll come back to that, or a HSW. The point is, if you were not using Studio, that's okay. You can just use Workspace with a connector, point directly to the HSW. You will not see any specs or actions or any of those kind of things if you're working in that mode. So we have the connector, it dumps information into a HSW about the bytecode and other things, and also Workspace now can be pointed at that HSW file. You need to click on the link button to connect these two together, and now you're connected. And that's a perfectly viable way to work with Workspace and an IDE. When you're using Studio, you can point Studio directly at jar files and Maven projects and various things. But to keep things simple for you, I recommend that you point your Studio instance. Anything you do in Studio, you're going to save it to a HSP file. I recommend you set up your project settings so that, in a sense, you're pointing your project at the HSW file that is also used by Workspace. It just keeps everything really in sync. So that's the way to do that. Let me go on to the next one. And then you have the option now to point Workspace at the HSP file. When you're working like this, the advantage is obvious. You're going to be picking up any of the artifacts that you create in Studio will now have an impact in the Workspace view. So your structure spec, your module definitions, your actions, all of those things now are now visible in Workspace. So this is really the best way to work. And then just to point out, you can also, using build, typically, but also you can do this directly from Workspace. You can point build also at your HSP, and you can get build to capture the information about all of your dependencies and all that structural information to a Structure101 repository. It will also capture any violations of your modules, your structure specs, and various things that are basically your build is driven by a build spec file, which lets you tell it really what to do at build time. And that stuff can get captured by the repository, in the repository, which can then also be viewed within Workspace. And also you can look at the repository in Workspace. So even if you didn't have access to the HSP information, you can kind of get it through the repository, but it'll only be as accurate as the most recent publish from build. So you can see there are various workflows you can do here. And also the dashboard then is driven from the repository. So it can be quite useful. If I come in the morning and as team lead, I check the dashboard, I hit refresh and I say, oh, hold on, there's some new violations got into the build last night. That's not good. I have a conversation with one of the programmers to check that out. The programmer can point directly to the repository to find out what is the source within Workspace. Where are those red and green numbers? Where are those red numbers that were the problems that were introduced last night? And I can actually jump straight to the code, assuming that's basically generated from the same IDE Workspace originally. I can jump to the code then for those things and make the fixes and check them back in again. So within Workspace, you've got 3 options for loading stuff up for Java. B would be the one that I would suggest is most common. The HSP and the HSW quite often would be checked in alongside your source code in your Git repositories and that type of thing. So that means that build can use the same HSP. The developers using Workspace see the same HSPs or the same specs and model of the code. And obviously the Studio user, everybody is using the same information, the same architectural understanding then is shared across the code, and that's what's checked at build time, etc. So that's the way I would recommend for that stuff to be used.